Next, in the remaining part of the functional programming, now we will focus on a new concept called as local global scopes. What do you mean by the scope and how it works? Generally, this kind of scoping is useful whenever we are working with something called as call by value and call by reference. This is a general programming concept. Every language will have these things. Means like some languages will be only call by value, some languages will be only call by reference, some languages will be both of them. Especially in Python, we can do both of that. So now what is this call by value? Means to a function, if you pass some values, what are the changes you make within the function will not reflect outside. So if a reflect outside, this is called as call by reference. Rather than going in a theoretical way to understand, let's go with some example. To work with it, let's say first understand what is this concept of globals and locals. We have two built-in functions also to help us. Other languages don't have this, but in Python we have two more built-in functions. What is this built-in function doing? So it is exactly telling you what exactly is the global scope, what is the local scope. If I say just a global, this is all like, just a docstring. I didn't write anything, just I'm making a print statement. Now you see what will happen. I got a lot of content. So generally, if it is like a ordinary print, we cannot see the things. I told you, right? Ordinary print will not give a dictionary clearly. If you want in a better way, what we can do from pprint, import pp. You can do like pp of globals. Globals is a function. You need to make a call. Now, did you understand clearly? Once you create one function, it will have this much content. So why sir this much content is coming? If you see, first one is name is equal to __ main. We will discuss about it afterwards. This is all metadata about that file. And what is this __ doc? Means what are the documentation you have given. If you remove these doc strings, you will not get that. And remaining, if you see, few other things are there, right? The built-ins. Built-ins means the built-in module. The exceptions, keywords, everything will be there with that. And __ file, which is giving the file name entirely. So like that, these things are there. Now, what is a local scope? So similarly, like this one, there is another thing called as like, so not only this pprint, we can give like pprint also. But only thing I told is like with pprint, things will come in an ascending order instead of in the same order. So in an ascending order, they're coming. Now to know more about this one, let's go for something like, if I say here, there are two things, locals and globals. There are two functions. So let me work with that to show you. So when I did like pprint of locals, I'll get locals. So this is a global, okay? Till now we have seen. Similarly, there is one more function called as locals. And did you see for locals also, you got almost the same content? So when I did like an assert, it is saying true. But why they will create two functions for the same thing? They will not create, right? That's the point. So what is this concept of globals? Why things will be different means? So let me take variables which are defined in the local side. Say like if I say number 1 is equal to 100. And instead of printing that, so I will comment these things and I will ask again what is a globals and what are the locals for you to understand. So now if I print the same things, did you observe that? You will get a hell lot of things are coming. Did you observe that in the global also, you got a lot of attributes and the last you have number 1 equal to 100. In locals also you got number 1 equal to 100. Then what is this, sir? Let me tell you. Now let me take a small function, say like, my func. Now within this, if I ask, hey, what is the, within the function, if I ask, hey, what is the locals and what is the globals? Same function I am making. Will it execute? No. Let me comment these things because it is humongous. So now let me make a call. Function call. If you make a call, you will understand that. Okay. So did you see now within the function, you were asking, hey, what is the globals? Now, did you understand the globals means what are is defined in the entire program? But within locals, did you see anything coming now? No. So now did you all understand that a slight difference is happening? Generally, what are is at the script level. This is what are is highlighted. This entirely is called as global scope. But within the function, it is called as local scope. So whatever you define within the function, which will be there only there. Let's say if I say number 1 equal to 100. So number 2 is equal to say 200. I'm defining number 1 and number 2. It doesn't matter whether I use or not. Did you see in the local scope, you got these two variables? In the global scope, you got number 1 equal to 100. That is how sir means you have defined in the top. Say like if I say number 1 here and say number 2 here and number 3 here. Means, this is also one point where we can prove if the same variable is defined both in the global scope and local scope, in the local, you will get the local value. Say like I'm giving here 200 and say here giving 300. Now, if you observe carefully, did you see that in the global scope, you got number 1 equal to 100 because you have defined. In the local scope, you got number 1 equal to 200 because that is what you have defined. So that is the difference between these two. Then, so I told that local scope, if you ask the same local scope afterwards, coming out of the function, then you see it will get the hell lot of things. So means locals is a functions which should not be directly called outside the functions. It is designed to call within the functions to understand what is its local scope, right? So these local and global are the functions which will help us to understand. So in other languages, you don't have this kind of scenario. Here we have good number of built-in functions to help us understand. Okay, sir. Now I understood these two scopes. What to do next? To understand next, let me comment this. So we understand good amount of things. So let me comment this also. So we understood it. Let me go for the next one. If I go for like first case, where I'm defining some variable globally, and I want to show the concept of call by value. Say if I define like a something like a simple function, and within the function, I try to print the values. So I try to print the values. So you will understand that. I got like case 1, that's it. Because I'm not making any call, right? Say if I'm making a call right now, you can notice that. I got like pi equal to so and so, pi equal to so and so. Means you are doing a string formatting and printing it. Now within that, sir, if I ask for the p print, will it print it? Let me show you. Because you are not defining anything here, so you are not able to show that in locals. But sir, without defining, can we use a variable? That is the beauty. Means global scope variables can be directly used within a function without without passing as an argument. This is something interesting. Okay, sir. This time, let's do a slight change. Let's do a slight change where I will do like one more action. In the first case, I defined outside and I used only. In the second case, I want to define use locally. So see, use before and like after I want to do, and I want to print the locals. So slight difference, right? I want to do. Now if you see here. So once again telling, I am not passing as an argument in both cases, but I am trying to use the global variables. If you see now, in the first case it is working, but in the second case it is throwing an error. Sir, why? So, and what is this error it is showing? Hey, unbound error, local variable pi referenced before assignment. So, see, what happens is whenever you are trying to update a variable, first it expects this variable to be present. So, okay, whenever you are defining some variable, it thinks that there is no variable outside. So then it tries to add it. For updating it, first we need to pass a variable. So the conclusion is that if you just want to use the global variables, you can use it. But if you want to update or modify that variable, so without passing as an argument, you cannot take it. Now, sir, so let's take the small case. The same thing I will do by just passing as an argument. So in this case, I will do like this. Compared to the previous case, here I'm passing as an argument. To make the things easy, I am using the same variable. But generally, it is not a good practice to use the same variable. Say this time I'm passing the same variable, I can execute. See, this function, I am not commenting it, but still it didn't get it wrong because I'm commenting the call. So the call is the one which will execute, right? So no matter whether function is defined or not. So if you see here, I made a function and I'm making a call. And the beauty here, you will understand something interesting. So you know outside what is the value of pi? 3.141. So ignoring the first and the second cases, you have the third case where what you are seeing before the change, pi value is equal to 3.14. Whatever you have given. Next, you are changing to 3333. So after the change, it is 333 exactly. And within these locals and globals, I don't want to print everything. So it is a dictionary. I am doing like a dictionary key. So what are the variable you define? It will be there, right? So I'm printing only that. See, local value is 333 and global value is like this. It is saying. Hope you now you understood. Global value is like this and local value is like this. And after the function call outside, you are asking, what is the global value? Means so and so. Means, did you understand? What are the changes you made within the function for the value pi were not coming outside, right? Inside, what are the changes you made? It's not coming outside. So this is called as call by value. Means you are passing as a value only, and what are the changes you make will not reflect outside. Next, I want to go for the one next use case. So I want to make the conclusion and then go further. So this time, so I want the local changes to be reflected outside. So that is called as call by reference. So whatever the changes you want to make inside, that you want to recognize outside. For doing that, there is one more built-in keyword called as global. Observe, this is called as global's function. Yes, whereas this is a global keyword. Observe the difference. If you want any local changes to be reflected outside, then you need to use a global keyword. But did you see that it is throwing an error? That what is this error precisely saying? Hey, you used the name pi as a parameter and global also. So if you want to use only as a variable, you can use it. But local changes will not go outside. But if you want local changes to outside, then use global. But don't use both of them. So that is what exactly it is saying. Okay, sir, I understood the problem. Now I want to do the same thing in a slight different way. So this time, if I define the same thing, I am not passing as an argument. If I pass an argument, I cannot make local changes to go globally. So I'm passing only as a global reference. So till now, you know, whenever you want to use a variable, you are just using, but you never initialize the variable, right? So this is the declaration. So the beauty is like whenever you are declaring something as a global, locally it will not create that variable. That's the reason whenever for the locals, if you ask the pi value, it will throw in error. So there is nothing in local scope. Whatever is then so and so it works. Now, in this case, if you observe, it will work perfectly because if I make a call, did you notice that before change 3.14, within that it has 3.14? Because we are using the global reference, what are the changes will be affected to the global? So after the function outside, if you ask, it says the 333. So don't you see that what are the changes you make within the function were reflecting outside? This is called as call by reference. So now we understood the two things. Within the function, what are the changes you make should not reflect or should reflect is your point. So in this particular case, I have used the pi, which is like a 3.14 something. This is a floating point value, means immutable object. For immutable objects, the default is call by value. So when global keyword is used, it will become call by reference. So this is what we learned, right? In summary. Now, I want to use the same things for different data types. Say this time I want to go for like a dictionary. So till now we have gone for immutables, right? Let's go for a mutable objects. Mutable objects means I define a dictionary where version equal to 3.16 some so. And within this, I want to change to 3.12. So before the change, what are is they coming? After that, I am changing to 3.1412 and it is printing. So now, as you are not defining this function locally, so till now what happened? When you don't define anything as an argument, if you make any changes, it will throw an error, right? But for dictionaries, it's not the case. Dictionaries means mutable objects. List, dictionary, set, these are all mutable objects, right? For mutable objects, without passing as an argument, still you can make the changes. And did you see what happened? So within that you have made a changes, and outside you are asking, say, hey, what is the value of it? It is saying that 3.12. Means inside locals, it don't have such key, that table, that's one thing. And what are the changes you made? They were reflecting outside also. This is something very interesting, right? So, sir, how it is possible, sir? Yes, that is how this works. This is call by referencing. So for mutable objects, by default, it is call by referencing. Sir, what if you pass as an argument then? So this time, again, the same call by reference, but this time I'm passing as an argument. Outside, I'm passing a variable, so dictionary called as details. Inside, I'm using a different variable called as lang details. It's a best practice actually. So if I do like this, then what will happen, sir? So if you see in this case, see here what will happen. Inside, I'm changing to 3.10. So before outside, you made it to 3.12, right? Now I'm changing to 3.10. Now, did you see outside when it is coming back, it is 3.10? In fact, when you see the address locations also is same. So means what you are understanding here. In the previous case, when you're not passing as an argument, it don't have a local variable. So it will say like no such key. Whereas when you're passing as an argument, it will have local scope also. But what are the changes you make within the function will reflect outside. Okay, sir, this is good. But sometimes you don't want the changes to reflect outside. Not every time you want all changes to go outside, right? So means how do you want to implement call by value for the same mutable objects? So this time what I will do, instead of taking the same logic as it is, I will do like one extra step. For any dictionaries, if you want to create a copy, so you do like dictionary is equal to dictionary.copy or like copy module. So whenever your dictionary has like multiple dimensions, you need to go for a copy.deep copy. And again, I will use the same things as it is. So what are the values are there? So I will use the same things. Say like I will make it like lang2. Yeah. Language details 2 is equal to so and so. I'm making and I'm using it. So in this way, if I do, it will become like a call by value. Means what are the values there? You are not making a changes to it, right? You understood that reference leakage and others. See, within this it is earlier it is 3.10. So now within that I'm changing to 3.11. So did you see outside? Is it clear? Yeah, it is changing. Now if you observe carefully, before the change, what is the value? In case 8, before the change it is 3.10. So after the change it should be 3.11, right? So after version change, why it is so and so? Okay. You are asking the details function outside and this local function. So both you are asking. So in the details, the version is so and so. So in the local, it is like 3.10. So local language details too. Oh, see here, what's the problem? You were changing on the same variable. So that's why you couldn't understand. So now if I change to a different variable, now we'll understand the difference. Yes, it is clear now. Within the function, you are changing to 3.11. It is changing to 3.11, fine. But outside the function, it is no more 3.11. It is 3.10 again. Means what are the changes you made within the function were not reflecting outside, right? So this is called as call by value. So now we understood this concept of call by value, call by reference, right? So now let's extend the same thing for a list. So to summarize the things. So if I take a list, I'm not passing as an argument, but I'm making some changes. Will it work? Yes, it works pretty much. So what are the changes you make within the function are reflecting outside also? So this is not expected means, so what you need to do? So you need to change it. So before doing that, here I'm not passing as an argument, but similarly, if I pass as an argument, then also it will make a change, but it will just create a local reference. That's the only difference, but it will execute again further. So in this case also, what are the changes we are doing within function are reflecting outside. Now for a list, if you want to make it call by value, so then what is the solution? You need to use the copy. So for a list, what I did, list.copy I'm using. Either the same name or a different name I can use. So now you understood this concept of, so by call by reference, call by value, and how it works for all the cases. Similarly, the last two things I want to say is call by reference. So if I do like, number plus equal to, so what will happen? You're passing as an argument, you are adding to the existing value only. You are not creating a new copy. In fact, this is one of the interview question. So in this case also, what will happen? It is called by reference only. Similarly, if I go for like one more use case, say in this example, if you see, what you'll understand, I'm taking some variable, some list, and I'm taking some value. So then what I do, I am doing like this kind of assignment. So colon equal to means the same value I am trying to take, and I'm doing some kind of logic. See, list comprehension I have done. So, and I'm assigning to the same object. So if you do like this way also, did you see what are the changes you made within the function are reflecting outside? So this is all the different things that you should be aware of. So, and the last things to go is like, within this, I have written like endless things of things. So finally, I want to conclude that for immutable objects. So for immutable objects means, so either like, list tuples, basic data types, tuple, frozen set, all these are immutable. For immutable objects, what happens is like by default, it is call by value. When you are using the global keyword, it will become call by reference. For mutable objects, by default, it is call by reference. If you create like a copy, it will be so call by value. So this is a conclusion about this functional and global scopes. Sorry, global and local scopes. Now, if I go one step ahead, so the most common question you will get about, so scoping is about what is the scope resolution? Means what are the different levels of scope you have? Means till now you told about global and local. Means you will have within the function or outside the function. But not every time only functions will be there. There will be furthermore. So there is a concept called as LEGB, local, enclosed, built-in, global, and built-in. So anytime when you are working, you should think about that. Say like, if I am asking what is the value of pi, so say like, to understand, so I have like a built-in value. So I'm importing pi value. So, and I'm trying to print the value. So then what happens? Whatever is there in the built-in, so you are getting that value, right? So clear and Python 016. Did you see? You didn't define anywhere, but you got like a built-in. Then what is a global scope? Global scope means you define at the global level, so we will get it. And then like if you go furthermore, within a function, if I define something, that is called as a functional scope, right? Say if I am taking a function and within the function I am defining to get it. Say like I'm making one more thing from pprint. So import pprint. Fine. If you see here, I am using a global scope here. So from the modules or somewhere, then this is a global scope, built-in scope, and like this is local scope, which you are defining. And this is called as like enclosed scope. This is very interesting. So means you initially define pi value as something, but within this here we are writing like this. Means you are doing pi for pi in so and so. After this, if you ask, hey, what is the value of pi? So generally each time it will go to each other value, right? For pi means like 1 or like 2 or 34. So in Python 2, there is no concept of enclosed scope. So if you ask what is the value of this pi, it will say it is 34 in Python 2. But in Python 3, whatever the local assignments will be within that only. So enclosed scope will not come outside. So whatever is outside global scope, sorry, local scope, that local scope value will come. Now if you see here, these were the various things you will get. So if I ask, hey, what is the, by default, what is the globals? You will understand what is the globals and what are the locals. So within the locals, we have like only two things, pi and the values. So here you define pi and here you define the values variable, only two things. What is the value of pi? So 3333 means what are the things we have defined within enclosed, you're not getting outside. So that is what I told. So next within this is a global scope I told. Now the point is, if I don't give anything, it will try to sneak to the higher scopes. If let's say, so you already understood about the concept of enclosed, leave it. What if I don't define it? So I don't define this pi value. Then what will happen? If I don't define the pi 333, what is the value of pi? What is the value of pi doing means 3.14. Means if you don't define locally, it tries to get the global scope. If I don't define even the global scope, say if I'm commenting this also, then it will go to the built-in, right? But if everything is there, then which one will be prioritized? Locals will be prioritized first, right? So that's why this concept is called local first prioritization. Then within enclosed, then the built-in, sorry, global, and like built-in, LEGB. So this is how the scope works. In the order also, first enclosed will come. So for enclosed, only things. Next to global, so local, global, and built-in. This is all about the scope resolution. So 4 types of scopes that we have and how we can use. Similarly, if I go ahead about these functions, the one last point I want to touch is on the partial functions. In terms of the partial functions, means till now you might have done multiple types of functions. But I want to introduce one new type of function called as partial function. What is this partial function, sir, means? So I am using a module called as functool. How I will use, I will tell shortly. So ordinary function, did you see? So I'm defining a function, I'm making 3 times. But did you understand in this function there is something very common? So if you observe the 3 arguments, so in 3 function calls, the first argument is same, right? So with this, I can create like a small thing. Means using functool, there is some concept called as partial. As the first argument is every time same, I will pass the function and pass the first argument, which is 2. So I will define a variable called as multiply2, which will be a function in fact. If you make a call, it will also execute in the same fashion. So if I make a call, you will understand that. Say, if you see here, I'm asking, hey, what is multiply2? So, and you see, multiply 2 of 4 is same like multiply of 2 comma 4. Means what is this partial function doing is, whenever you have multiple function calls and some values are common, it tries to help us. Means it will not create a new function. It will work on the existing functions only, and it will do something on top of it. You see, if I ask, hey, what is the multiply to? It is saying functools.partial, which was created from multiply function by passing 2 argument. It doesn't mean that only one argument. You can pass any number of arguments. Say, let me give you one more example. This time, let's say the same function call you are doing, but this time you are making like this. Means first argument is different, but the second argument is every time 2. Then if you want to create a partial function, you can use like that. So explicitly it should be taking as the second value. Then I did like y equal to 4. Why exactly y? Because here defined as x and y, right? To which one if you want to register, I specified that. Now if you make like multiply of 12 comma 4 or multiply 4 of 2, 12, both will be the same answer. This is all about the partial functions. In fact, like, I have created like multiple partial functions for that to explain. So you can give a try of creating one kind of calculator option using the partial functions. You will slightly understand how it works. And also to show the built-in functions. You know how the built-in functions called as the int work, right? So for int also, if you want to create, so int can work with different bases. You remember I converted like binary, octal, hexadecimal, etc. If I want to do only for the binary, so from int, I'm saying base 2 as a thing, and I'm creating base 2. So in fact, for this, if you can write one docstring also. So this int of like binary of base 2 is same like this one. Similarly, for the bin function also, if you want to create a partial function, I can do. So what I want to conclude is, if you have any function, either user-defined or built-in, and if you are using multiple times, and if you want to do some kind of optimization, you can go with this thing. So the next thing that we want to touch is, after this, partial Euclidean. So this is one example I want to bring to your notice. So generally where partial functions will be used. Say use case I want to bring is, um, yeah. So I have one problem where I want to calculate the overall distance of execution. See, in this problem, there is a Euclidean distance code. So Euclidean distance means you give 2 points in Cartesian coordinating system. It will try to get the distance between them. So for calculating distance, you are giving like this. And did you observe this in both cases? The first point is 0 only, 0, 0. So for this, I created like a partial function. See, I did like a selective import. So only partial. And I'm passing the Euclidean distance. And I'm passing the first point. Now we see Euclidean distance of both the points you can pass are simply 0 Euclidean like this. Means you are trying to use in your day-to-day life these partial functions. Similarly, after the Euclidean distance, the next thing that we need to go is called as like lambdas. So we can see it afterwards. Next, we can see into the Lambda functions. What is the Lambda function? In which case we need to go with the Lambda function. So we have unofficially learned about the Lambdas earlier also, but now we will learn much better. So what is a Lambda function? To understand that, let's go for like an ordinary function. If you see in this case, I have a function called as a double, which is taking like one argument and it is returning twice of it. So Lambda function can be suitable in this case, where when you have a one line execution, then it is very much suitable. So when you have this function, the same function I can mimic using a lambda. Lambda means an anonymous function, a function which don't have a name. Sir, what is a function which don't have a name? Yes, we use a lambda keyword and write the same x stated. So here, if you are given an x, you are doing this logic. So the same thing I will write. If x stated means f given x, you want to get this one. So this is the logic. The same function I did like this. As lambdas don't have any name, let me assign to some kind of a variable for better usage. So now for this particular logic, if I say dbl of 2 or like dbl of 3, this is same like this logic. If you see, both will give the same answer. No, sir. So this is what you understood about a lambda. And in fact, if I do execution, so I can do the execution directly. If I say double of 2 or like dbl of 2, both are same. In fact, this dbl is a variable. In reality, we will not use a variable every time. Lambdas are suitable whenever you want a logic to be executed only once. A function, if you want to use like once or twice only, then there is no point of rewriting every time, right? So in fact, in reality, they will execute like this. They will not even use a variable to do. So means like here, see, lambda stated x into 2, and this entire thing was placed in a enclosement, right? I told about the enclosure scope. And for that, you are passing 3 as an argument. So now, don't you think that this is a function which has no name? It is executing only for that instance. So that's why this is called as anonymous function. So most of the languages these days are having it. Sir, what is the point of going for this one? Will it make any much difference? No. To understand that, I am trying to get the size of both of them. Both this double function and this lambda function. Did you see that there is no difference in the size? Both are functions only. Both ways we can use. So what is the advantage it gives in terms of usage? If you are defining a function globally, that function will be there for entire code. But what if you want to execute for only one small time? Unnecessarily you are storing in memory, right? So to avoid that, we can go. Let's take the another example. If I go this time with a binomial expression, I am taking an input n, I am returning this entire value. If I ask, I will get the answer, binomial expression. Now for the same thing, if I want to replicate, I can create a variable called as binomial expression and assign it to lambda. So if you are given a n, so n stated, what is this expression that you want to return? That you write it. Now, whatever we have done earlier, the same thing I want to do. Means I want to do with like binomial expression of 10. Now, did you see that both will give the same answer? So why this is possible? Because it is a one-liner. Similarly, if I go with one more example, say like, here I have a print statement which is taking 2 arguments and it is printing hello first name, last name. Now for the same function, if I make a call, so with like a lambda, so if I want to make, as we need to have some variable for reference, I'm just using, say lambda, say like fn, comma ln. Means it doesn't mean that same thing should be written. I can write any variables, right? So within my logic, I want to use it. So as like a first name and last name are big, I will do like fn and here ln. So like a simple way of referring. Now in this case, both are returning the value. And if I do an assert statement, hello of Gudo resume and like h of Gudo resume, both are same. In fact, you should know that this guy called as Gudo one resume, he's the person who created Python. So this is a small point. Next, let's say you have some function which is executing like this. Say, if you want to check like the even or oddness of a function, you can check like this, right? Whether something is even or odd. But if something is like this in multiple lines, we cannot create like a lambda for it. Lambda function is suitable only when you have a one-liner logic. Can I convert this to a one-liner? Yes. So using like, ternary operation, we can do that, right? So what are the condition is there? I write that. If this condition is true, what we want to do? This if condition result. And if this condition is not done, then else you want to do something else. So in this case, I'm able to do the same in a single line, right? Now this logic can be implemented. Say like some variable I'm writing, lambda, you are given like a single number stated. What are the logic? So why I should use number only? I can use n also. I can write the same. Means it is up to us. What are the variables you want to use and others? In reality, what will happen? If I compare the results of both are same. In reality, things will be much more different. They won't use any variable to define. In fact, that is for your understanding as you are in the beginner stage. But in reality, it will be like this. So directly lambda will be taken and you pass as an argument. So you get the result. Similarly, you have some logic. Say like you have a another example where you have a tuple. From the tuple, you want to get some element. You want to index and get. So the same thing I did with the lambda. So to do it in much faster way. So sorry, not a fast, just like a rearrangement only. But sir, what if I do say slight difference? This is one of the interview question. If I do like a simple function, which is returning a message, this is pretty sure, right? So if I make a call to this function, say like, I am trying to say, if I make a call directly, say wish of, say happy birthday. If I do, what will happen? If I execute it, it will execute it. But you won't get a result because it is a return statement. So I need to write a print around it to get the result. This is what we know. To make the things much better, so I try to assign to a variable and get the result. That way also I get the same thing. Similarly, now I want to do something interesting. So instead of executing this one, I want to return a lambda. What is this lambda doing? If you are given some kind of a name, okay, I want to give a message. So if let's say if I'm saying like, if you are given like a message, I want to get the message. Now, did you see that both are doing the same job? No. Did you understand the difference? So this is the extra function I'm trying to say. If you return a message, that is fine. So this is seems like a function. No, it is returning one more lambda function for you. So means it is returning a function, not the direct thing. Did you observe? Means for this greet is now a function. It will accept the values. What are you pass? Say like if I pass, say like, Narendra. So now what will happen? It will execute and it tries to get the result. So as it is a print statement again, I need to have a print again. So now if I see, did you see that I got Narendra? Fine. Or like the second name you don't know, right? So let me tell you. Now I will modify it better. The second name is like what are the name you were given. So then what I will do. So in F string, I will write the message and I will write the name. Now you will understand more clearly. Message is something which you got in the first call. Name is something which you will get in the second call. In this case, message is this one, happy birthday. And the second name is name. Now, if you observe, you will understand it is happy birthday, Narendra. So did you understand how it is working? Or like you can do some kind of better logic. Instead of just printing that, say like, I want to do like this. Lambda name stated that message dot upper and so and so. Now, did you see happy birthday, Narendra? So similarly, so I can do the same function with different kinds of arguments to help you understand. You can walk through it afterwards. You will understand something. Now, did you understand what is the usage of this kind of combination of functions and a lambda with this kind of combinations? So these were some kind of things. Next, we will see about this uses of lambda. In real world, we will use lambdas whenever you are working with higher order functions. What are the higher order functions? Means zip, map, filter, reduce. Why are they called as higher order functions? Functions which are designed to work on other functions, but they don't do any logic. Means they don't implement any logic, but they work on another logic. So in which cases we can go? Let's see the first thing. So if you want like odd numbers from a given numbers, you know the first and traditional logic is that we can loop over some values using range, and every time you can check whether it is percentile 2, means not divisible by 0, then we can get it. If I do clear and Python 0 to 0, should get it. So did I define it outside? No. So Python should get right. Okay. I didn't define it like, dot py. Okay. So now if you see, so Python, did you see you got the answer? So fine. This is what the traditional way. Now the same problem, we can implement it with the list comprehension also. Using comprehensions, how we will do? The same problem, how we will solve? Odd numbers, say 1 is equal to, in comprehension, I write the same logic like if for loop. Within that, I am doing this condition check. So I will write that condition also. And after checking that, I am taking this number. So I will write it. Now, if I print it, so both will give the same answer. If you see here, both are giving the same answer. Fine. Now, the same problem can be solved in a different way. So in this case, you have very small logic, percentile check. What if you have a big logic to check? So you cannot write all the logic here. Maybe you need to write another function and do it. So for that, we can go with the next way, where you define a function which will check whether it is even or odd. It will give a true if it is odd, else it will give a false, like that. Now we can use the same first function by modifying it, by saying like this. Means instead of using this condition in the if condition, I am using this another function. So this is a common sense, right? Whenever you have a large thing. So even here also, we can replace it with this function, right? So that is what we learn. Now, whenever you have this kind of function, which you need to be applied, if you clearly understand here, this function is applied on each of the value. It's not like the 9 numbers are going to that function. Each of that 9 numbers, for each of them, we will pass this function and do it. So in these scenarios, we can have another way using the apply function. So for that, what we need to do, we can use a built-in function called as map. This map will take that function whatsoever you have. You have this function, whatsoever you want to do, and this function you want to apply. So to what? The range of these numbers. So instead of you implementing in this much way, you can simply write like this. So map of these two. So now if I assign the same result to something like, odd numbers 3. If I print, hey, what is odd numbers? Map is a built-in function. So if I execute it, what it is saying? Hey, you need to pass a comma. It's a typo. If I clear the screen, did you observe that what happened? It is saying that I'm an optimized object. I cannot give you the values directly. So for our convenience, for time being, as you know that this is like an optimized object. If you want to get the values, the one way is like either do like a for loop or convert to a list or something. For our convenience, temporarily I'm converting to a list. And observe, map will return a list in Python 2. In Python 3, it is an optimized object like this. For our convenience, if I ask, did you see you get the same answer? Means instead of you writing this much logic, you can just do it in a simple way. So when you do like this, first we should have functions. Every time people will confuse. First we should have a function. Say function will be applied on one or more iterables. It is not like multiple functions you have and you get the results. See, but you got like the result as true or false. You are not interested in this true or false, right? You are interested in the final numbers. So for that, they modified with something else called as filter. Instead of a map, we should go for something called as filter. So what is this filter doing? How it will be helpful means simple. So wherever the condition is true, only those results will come. Did you observe in filter? For when we apply the function, if the function is giving like a boolean true or false, it will check. For whomever it is boolean true, only those will come. So interesting, right? Now, the same logic we can modify slightly. Instead of this much function, you want to do with a lambda functions. Did you see that instead of this function, I'm implementing with a lambda? So this is what the most professional way that you will see in real time. Means they will implement a map, write that small logic immediately. But if you have a big logic in more than one line, then lambdas is not suitable. Of course, we can write a logic. Even you might have solved some problems, right, by now. Using a comprehensions also you solved. Using a typical for loop also you solved. But the difference is readability will go. So things will look very complicated. When debugging, it would be difficult. So that's the reason. So you need to have a clear clarity when to use lambdas and when to use an ordinary function. But it will not do any performance. It is a comfort and so unnecessarily making the memory waste. So now a small assignment is that you need to get the prime numbers between these two values. Both numbers are inclusive. And you can use a filter for filtering the final results. Hope you understood about these higher order functions. Now going further within the higher order functions, next we will see about after the map and filter, the next one is like zip. What is this zip doing? How it can help us? Hope you remember we already discussed about zip earlier when we are working on dictionaries. Zip will take two values and give that list. If I give like a two values and if I ask to get the group, say if I say result equal to zip of group A group 2, if I do, and if I ask to print the result, you can notice Python 021. Did you see that again? This is also an optimized object. So all the higher order functions became like an optimized objects in Python 3. In Python 2, it also used to result in a list only. In Python 3, they made like this. So for our convenience, we can convert to a list for time being. So you can see the result. It will be like a pairs. So the first value, zeroth values, first values, second values, like that it will go. And if there is asymmetricity, it will ignore the remaining values. And the beauty of it is that the result, if you are passing to something else, that will give what? So the result, if you are passing to a dictionary built-in function, it will result in a dictionary. But dictionary expects like a pair. When you have two values only, it can do. Similarly, if the same things, if you are giving, if you change the order, then what happens? The keys become values and values will become keys. The same thing if I give further. If I want to create a dictionary, I need not convert to a list, right? Just to show you. But what if I took like one more group and I ask? So means like instead of 2, now I have 3. So group A, group B, group 2 and group 3. So if I ask now, I will get the pairs like this. So whichever is minimum, you will get that much size. But sir, what if I pass these values to a dictionary? Does a dictionary work if you have more than one values, two values? No. So value error, sequence has like a zeroth value, two values it expects, but you gave three values. You're saying right? 0 has length 3, 2 is required. Means only two values only it can take. But zip don't have any such problem. If you give any much also, it can work. So, and also, just to give like one example, if you see, it is clearly to understand. It is a print function within that list for us to visualize. But this is the actual zip, which is taking three values. So in this way, you can clearly understand, right, what's happening. And similarly, there is one interview question. So means like how to make map to work like a zip. Generally, map is designed for what? Applying a function on a iterable. Whereas zip is what? For combining all of that. So if you want to do like that, you can do in this way. In fact, like map used to take something called as a none in back in Python 2. In Python 2, what it used to do? It used to take a none and it used to work. If I execute, it will throw an error now. So none it will not take now. But earlier, so the same logic, instead of doing like this, we used to do with a none in Python 2. But now we cannot use a none anymore. So like this, we can use. Next, so if you have like some kind of logic, say like in this case, you observe, I have is positive, some logic. I'm doing a map filter that you understood, right? So similarly, you did like the Caesar cipher implementation and observe the same Caesar cipher I will implement in a very short way. For implementing it, so first I will do is what? I will create like this. List is for us to visualize, but generally map. I'm giving one function and a string. It's not that every time we need to give a range of values. You can give a list or any iterable. Any iterable such that it can loop over it. Now if I execute, did you see all the characters individually? Now for each of the things, I want to do one more shot. Where instead of for each given a character, I want to get the order of it. Order means like the corresponding ASCII code. And what you did, you have added like, 3 to it. So you can add a 3, you get the result. So what is the next value then? Now, if I go back, so means like, if I am for that new value, I'm getting the character. Did you get the character now? Now, if you have like a list of strings, if you want to combine them together, we have delimiter.join, right? Delimiter.join. If I pass that result, I'll get it. Now, did you see whatever the logic you have done, using a Caesar cipher, you can do in a simple sort. Now you can enhance it by doing a percentile 26 to get like the round robin value. So between that, numbers only. So don't you think it is much more interesting? So fine. So like that, it's gonna work. And it doesn't mean that every time you should apply only one. If you observe in this case, see it has a filter and that is again passing to a list. So this list is conversion only for our visualization, but just I'm passing it. You see now, it will work. This is kind of like interesting. So a filter first, that results you are passing to another map. So like that, we can go with this kind of combinations also. So this also works. And the last point within the higher order functions, which I want to touch base, is about the reduce. So that is another important thing. .py. So what it does in reduce is that, so earlier reduce is like a built-in function, but in Python 3.x, so we don't have like it as a built-in function. So we need to import it first. If you want to use, we need to import it. So functools is like earlier, you remember functools.partial I told. Now functools.reduce is another thing. If you want to use it, so there are different things that we can do. So to understand about how the reduce work, let's compare it with the map. So till now, what you know about the map? You have a function, you apply that function on a iterable of values, then you will get the result. You got the values. For each value, you are trying to multiply by 2. So you're getting twice of each of the values. Fine. Now, the same thing I will apply by passing 2 arguments. In this particular case, lambda is taking 1 argument. Then what if I pass like 2 arguments for the same lambda? Will it work? No. So till now, I didn't tell one edge case for you within the map. Map, till now what's happening? You are passing 1 variable, it is taking 1 list. But if you are taking 2 arguments, so what it is saying, hey, missing 1 value for positional argument y. Means for a x, it is getting how? The first list. Means in a map, if you are defining 2 arguments, then you need to pass 2 values. So 2 values means like 2 lists separately. Only then it will work. So for if you have like 2 values and adding, then I need to place 2 lists separately. And observe here, it doesn't mean that 2 lists should be there. Any 2 iterables, 1 list, 1 string, 1 thing, anything can happen. Stated that here the logic is handling that. So if I execute right now, did you notice that? So the values in the corresponding locations are getting added. So 1 is getting added with 11. So you are getting 12. So like that, everything will happen. Next, if I go with like 2 values, it doesn't mean that every time it should be strings or lists. Can have something else also. You will get the result. Fine. Sir, what if I have something else? Say, I have like this, a combination of both. Means I need to pass 3 arguments, but I'm using only 2 arguments. Does it work? Yes, it's up to you, right? In a function, it doesn't mean that all the arguments passed should be used. I am doing like I'm passing 3 arguments, fine, but I'm using only 2 arguments. Does it work? If I execute, so it is working perfectly because you are not using the last argument. So, but if I try to use the last argument, that's where it's gonna use the problem. Say, if I'm trying to use like a plus z, will I get it executed? If I execute, it will throw in error. The reason being, if you observe, the first 2 are like integers, strings, right? They will concatenate. But the last one is like what? It's not a string. So it's an integer. So that's why we couldn't do it. So either you convert all the values to something, or in the last value, you can change it. So simple case is like to address this problem. So we can solve like this. We can solve by doing like this. See here, I am converting the third value to a string. So I can do. So like that, it is up to us what logic I want to implement. So like this, what is the reduce doing now? What is the point of reduce? Why we need to go for reduce? Let me go for the reduce now. So for reduce, you pass like a single lambda only, and you need to take two arguments only. You should not take like more than one. So more than two or less than two. So and it will, you need to pass only one list. So what is it happening, sir? It is very interesting to work with the zip. So sorry, reduce than anything else. As I told you, reduce is not like a built-in function. So we need to do like from functools, import, reduce, selective import. You see here in this case, what's happening? If you are giving like this, some values, then it will go to each of those values and execute it. Means, if you observe carefully, if you are given a list of values, it will go to the first two values and it will execute whatever you do. And the result will go add with the next one. The result will go add to the next one. Did you see how it's happening? Similarly, so if I go with like one more example, like a factorial if you want to implement. So factorial means what? So from 1 onwards till that number, everything should be doing. So if I take two numbers and multiplied it, it will go to each of the number and multiply, right? So don't you think it is same like factorial of 4? Similarly, so if it is up to us what you want to do. Say instead of you generating these values, you can write in much smarter way. Because range will go till the last value but doesn't include the last value. I'm doing a +1. So like that it will work. So reduce, we can work. And there is one interesting point that if you have like a factorial example, if I have the example of a factorial, how do you calculate the factorial? You take the number as result as 1 and you loop over each of the value and multiply it and add to the multiply to the result. So that is how you get it. And if the same thing, if you want to implement with reduce, I can use the reduce function. So lambda, standard way, it will take like two numbers. Say like, number 1, comma number 2, if I were given. So I want to do like number 1 into number 2. So like that lambda we can write. So whatever the logic we want. So don't you see like, it is not like a direct implementation, right? So not every time. So it should be exactly same like the others. We can do whatever works for us. And then for that, we need to give the range of these numbers. So whatever the numbers you have, we can do that. So if I do like this now, for the same logic, reduce of two numbers, state and multiply them. And if I give this one, so it will work perfectly for the same result. Did you see? So this is all about it. Now, a small extra point that I want to bring to your notice is about same like this. There is one module called as operator. So you may think like this is a small odd operator, but this is many people will use it. What is that you can see here? So if you ignore the things others, there is some kind of basic things like float, I float, I int, like that there were things. So what is this operator generally used means? Say if you have something to execute, means if you have two numbers, if you want to add them. So when you have two numbers to add, what you generally write the logic as? So every two numbers you want to add, reduce. So lambda. So a comma b, if you are given, you want to do a plus b, right? So that is a common thing. Now what this operator module does, it has attributes for addition. Means instead of you doing this logic, you implementing a lambda function. So you have ready-made. So it is up to us whether to use or not. There is no much performance improvement, but you can rely on the built-in things. Similarly, if you are given two values, you want to multiply them. So there is something called as operator.multiply. Mul. Similarly, this add doesn't mean that they will work only on the lists, so or the integers. Say if you see in this case, so operator.add. So we can use that also. and you have like strings. As everything is same, then it can add. Sir, we can use a plus operator, right? Yes, of course. But it has that option, so we can use if needed. So there are like multiple other assignments which I have placed. So you can try doing some things by mimicking a sum built-in function. So using the user-defined function and using reduce. So some function what it will do? If you give in a values, it will try to add, right? If there are different types also fine, but everything internally should be of same type. Then we can pass that extra value, it will do. But if you give the third value, so if everything is same, even one of them empty also, it works. Yeah, so this is another module called as iter tools. I will tell you about it afterwards. But why I'm coming to the iter tools is like here, I made use of iter2.accumulate. Let me show you something interesting. Generally, Lambda stated this both plus if I say, all the values will be added and you get only the final result. So yes, even if you do operator.add, you get the final result. What if you want to get the cumulative result? Cumulative means like for that position, from the starting till that position, what is the sum? From the starting till that position, what is the sum? From starting till that position, what is the sum? Like that. So this is all about the higher order functions. Next, going further, we have some interesting point called as recursions. So what are recursions? How they can help us? Especially, this is one kind of programming paradigm. In reality, any problem can be solved in two ways. One is an iterative approach, other one is like a recursive approach. Iterative means like for loops. So till now you have used for loops, you know about it, very familiar. And the next thing is using recursions. In recursions, so you have one function, it may take some input arguments, and in the return also you will have the same function name. Did you observe? So if you want to know more about this, there is one built-in, so there is one visualizer to help you understand. Say if I have one function which is returning the same function. So within that I'm writing hello and I'm returning a call to the same function. So now if I need to make a call to this hello function. So if I make, you will understand like how it is visualizing, how many times it is going. So what is that? So when I did it, it will not go, it will die because it is going infinitely. There is no stoppage, right? Rather, so I think it won't work. Yeah. Rather, if I take the same example and I place it, say like define hello, and if I say like, so here it is one kind of visualizing tool where we can visualize like how much time it is taking. Say if I do like a return of hello, and if I make a call like to hello, so you can see that how it is executing. Fine. So typical call is like you are getting a return. When you make a call, you are getting hello. But what if I am making instead of that, say like, hello as a call. Then if I execute, so it will take like crazy thing. Means the same function is going to same function again and again, again. It is stopping. So you are finally unable to see it. Even if I do the same thing here, you will notice that how much time it is taking. Say like define hello, return hello. And if I make a call to it like a hello, so in this case here, it would be very strange. Python 023. If I execute, see, and if you go for other languages, it will go like infinite language times. But did you see that it stopped else? What is saying? Maximum recursion depth executed. So we are unable to execute it. First of all, did it execute at all? To understand that, let me do the same thing again, but I will make like a print function. Say like, hello. so that you will understand. If you observe here, it is executing for n number of times and finally it is breaking. So when it has broken, it is saying the same error. Hey, recursion error, maximum depth reached executing while calling the Python object. So what is this maximum recursion depth? So why it stops? Before learning, so what we understood here is that whenever some logic is executing for infinite amount of times, in reality, it will not execute for that much amount of times. It will in fact wait. After a certain time, it will stop. So, okay. Now coming to the case of the recursions, I told that any problem can be solved in multiple ways. Let's take the example of a summation, because that is the most common thing. So a summation function can be implemented using a for loop. I can take a total, I can loop over each of the value, and I can add to the existing value, and I can get the final result. This is a typical way of doing with this. Now, the same problem, if I want to address with recursions, how to address that? So in recursions, you can define, but the problem that we learned is like it can go to infinite recursions. So to avoid infinite recursion, so we need to stop. That I will do. But first we need to know is that we need to make a call to the same function. So what we will do in recursions is like two things. We need to return the same function. At the same time, we should have a condition where it stops. So what I will do, I will take for this number, I can say like, hey, get me the 0th value plus from the first number onwards, you want to pass again. So then like second, third, like that it will happen. Now in this case, if I go further, say if I print like, hey, what is the value that you are getting? I will explain how to write the condition for you by doing it. Say like, I want to execute the same thing. I should get the same result. Now if you see what will happen, 023. Did you observe some interesting thing happened here? So initially you are passing all the values. And in the next loop, only from the first onwards you are getting. Why? Because every time you are taking the 0th value, right? So every time you are taking the 0th value. So like that it is going. Finally, at one point, it is having empty. So instead of waiting all the times, so it is saying like, we can stop when that particular thing is done. Means when length of numbers list is equal to 0, you want to stop. So how do you stop? For stopping, we can write a return. If you do like a return statement, it will stop. But there will be another problem. The problem is that when you don't return anything, none will be returned. So finally, after your work, the none will come here. As none cannot be added to an integer, it will be an issue. So for this one to add, for summation, if you write in a 0, it makes no difference, right? I will do now, you will notice it. So if I clear the screen and execute again, did you notice what happened? It is going for each of the value and trying to add, and finally you got your result. Fine. Let me comment now. So you get the same answer, right? This is how it is. Now, using this particular function, let us go into that particular thing. In the visualizer, if I place it, and in the mention call, I need to pass this call. If I pass this call, let's see. If I execute, did you see? Now it will help. You just know you saw, right? Every time how it is working. First, you are making a call with this one. So that is in turn making a call with the remaining values, excluding the 0th value, excluding the 0th value, excluding the 0th value, like that it goes. At one point, it is empty. In that case, we are returning a 0. So that 0 will be added to this. 1. So 1 will be added to this. So like that, everything is like a frame. Just imagine like if you are working on a multiple books when you're referring. So what you will do on a table, you will place all the books, right, to go through. Then if you assume that, a table is like a finite thing, you can open like only few books. After 4 or 5 books, your table will become big. You cannot, there won't be place for another book, right? Just imagine in the same fashion, whenever you're creating each of this thing called as a frame, it will store in the memory. Memory means, again, I told heap memory, right? So private heap. So that is also limited. Beyond a particular limit, it cannot accept. To avoid the Python to crash, they have set some limit on the number of such frames. So what it is saying here, maximum recursion depth reached. What is the depth that it is maximum allowed? That we will learn shortly. Similarly, the same problem can be solved in a different way also. Means it doesn't mean that every time we need to take only the 0th value and add to the remaining. The vice versa also can I do. So what I can do? So what I can do is like, I can take the 0th value and do, sorry, yeah. So if you observe here, I'm taking the 0th value and I'm doing this aim operation. So here I'm doing what? When it is 0, I'm doing like a return 0. Rather, when it is 1 itself, return that 0th value. So then you don't even go to the next loop. So like that you can do. One more example is string reversal. If I have a word, I need to reverse it. Every time I take the 0th value, place in the end. So like that I reverse. At one point it will become empty. Then we can return an empty. So similarly, the same thing. Here, observe the difference. You are taking the first class character and placing in the last. Here you are placing the last character in the first. So concept is same. The way that you are implementing, so maybe slightly different. So this is all about the recursions. And the last point within the recursions is, we can use recursion for solving any problem. Let's take some real problem like, say, I want to work with factorial or something. Generally, what factorial means, hope you remember the factorial calculations. Factorial means like, if given a number, from that number, you need to go till 1 and you need to add, multiply with all. So this is how you do, right? So this is called as a docstring for a function. So, but like here, what you are seeing, every time taking the number and multiplying with the factorial of -1. So it will go to the previous ones. So this is how the logic works. So, but if the same thing I need to implement with the recursions, so I can implement that in different ways. If you observe, so the same problem can be implemented in different ways. So this is like a iterative approach. Sorry, recursive approach, right? So we are taking the same function and doing it. So for that, if you want to understand this also, I can go further. So I go back here, I can pass it, whatsoever it, this is the docstring. So about the documentation, and if I pass this one, and if I say factorial of, say, like 9, if I do like this, what will happen? It will do like this. Now, did you see for 9, how many frames are creating? It is every time going to the previous value like that. So, but what if you are going for, say, some 999 something? It will be crazily big, right? It will go to the very big thing. So that is the reason recursions people don't prefer, because it is memory intensive. But the same problem can be solved with the lambdas or like, different ways. Means a problem can be solved in different ways. So, but we can do whatever we want. Let's take the example of a Caesar cipher and we can stop the recursions. Let's take the example of a Caesar cipher to understand. If you are given a sentence, every time we need to convert that character, right? So one of that character and do it. So what I will do, I will take every time the 0th character and do the operations on it and do it. So for returning it, I will return same Caesar cipher, right? So that is a concept. So whether you return this entire sentence or not is up to us. But this is a recursion. But they should have some kind of condition to stop. As it is a string which will have some length, When the length becomes like empty, you can stop. So when the sentence is equal to empty, so you want to return so an empty string. So in this way, I want to do. Say I am giving the Caesar cipher saying like, hey, I want to execute. War is planned at the morning sunrise. If I execute and implement it, Python 024, did you observe what happened? So, okay, every time I'm doing the same sentence, I wrote a condition to stop also. But is it going to that condition or not is the question, right? So every time if you give the same sentence, when will it become empty? Only when you give an empty string only it will become empty. In other case, it won't do. So, okay. Now let's take this sentence. In this sentence, I want to take the first character. Say first char is equal to sentence of 0, right? So that is for sure. So for this FIRST, okay, first char. For this character, I want to do some kind of logic. So for this first character, I want to convert to the ORD to get the corresponding thing. ORD of this first character. So for this first character, ORD, and you are trying to add some 3 and then converting to the CHR to get the corresponding character. So means you get like a n-ciphered character, right? So first character and you are getting the n-ciphered character. So as every time you are getting the first character, so Caesar cipher means the same order you're trying to add. As you are getting from first character, means 0th character you did, from first onwards, you pass to the remaining. Now, if you see in this logic, every time it goes and tries to get, if you want to understand further, you can do. So if you want to do like a percentile, 26 or something, you can do that and then convert the final result, whatsoever you did, and you want to do like percentile 26. And you know about the concept of PEMDAS, which will execute and you will get some result. Is it so? PEMDAS parentheses exponent division. So first division will happen, exponent will happen. So if you want it separately, you can write like one more logic with a braces, then you can see the result. But you're getting nothing. So that's what you should be careful about. See why it is not getting in others. So this way you get it. Now, based upon these recursions, you have like a couple of assignments where you need to write a recursion function to reverse a list. So means take the first value and place in the last, or last value place in the first. Similarly, using recursion, implement the Fibonacci series. Fibonacci series means the first 2 numbers will be 0 and 1, and subsequently every number will be, say, an addition of previous 2 values. That is all about the recursions. And Fibonacci series, as I gave an assignment, I don't want to touch it, but I want to go to the next one where I want to tell about these infinite recursions. So till now, I didn't deal about the concept of maximum recursion depth. So to understand that, let me go for this. We already know about this maximum recursion depth, but how and what is that limit? Let's see. If I go for this example, I'm using the word called as like display of name. It is printing and again replying the same. So it is executing for some time and saying like maximum recursion depth reached. So every time the standard error that we are getting. So how to handle this problem? So there is something within the thing called get recursion depth. Using the sys module, there is something called as get recursion depth. So what is that sys module get recursion depth doing means? So if I say sys dot get recursion limit, this get recursion limit will be by default 1000. So it will tell what is the limit. In a typical limit is 1,000 for the script mode and 3000 for interactive mode. Interactive means in the Jupyter notebooks or the IPython. or like Python environment. And if you want to set this value, we have one more attribute called as set recursion limit. Get recursion limit to get the limit, set recursion limit to set the limit. So if you set it, it will execute. But sir, what is the maximum that we can set? You can set in MIG also, but be careful. Say, assume that your your table can handle only like 4 or 5 books when you open and place. What if you have 30 books? If you make say limit as 30, it will go outside, right? So to avoid that, so you should be careful. Whenever you are increasing a limit, be sure about it. But sometimes there will be genuine case where it will go to the limit more. Okay, sir, I increased this limit. So if I increase this limit, does it work now perfectly? If I use the same display again, will it execute? Yes, it is still executing. But after 1500 also, it got a recursion limit. So that's why it was broken again. Now to understand how many times it is actually going. So you need to have that kind of count, right? To understand that kind of count, so let me go with one kind of function where this time I am not just looping and printing. I am taking some number and I'm incrementing it. So it is, see here, the interesting point. Number of recursions I'm taking. What are the recursions that are there? I'm trying to do +1. So if I do like a loop of say 0. Now, if you observe carefully, you will understand. Did you see that the loop is starting from 0 onwards? For everything it is going on. So, it is going till like 1496. But we have make the limit as like 1500. Means 4 frames are used for like the basic things. Means the basic system to execute and others. So if you change that limit, if you don't change this limit, let me comment it, set recursion limit. Then what will happen? Default is 1000. It will go till 996. So every time 4 frames will be reserved. The 4 frames will be used for like this main program and others also, right? So that like the things it will work. Similarly, if I have like a mutual recursion, when you have a single recursion, it is easy to recognize and handle it. Sometimes it would be hard to identify what is a mutual recursion. Mutual recursion means like, I say I am defining 2 variables and I'm passing it. See, the first function is returning not the first function, but a second function. So technically it is not a recursion, but if you see further, the second function is further returning a first function. So it's like a zigzag, both are executing. So now if you execute like the function 1 or like function 2, both will return in a recursion. So as 2 functions are there, it will not even go that much time. It will reduce the total amount of time it is going. So that is all about the recursion limit and how the mutual recursion happens and how we can handle. Sometimes if you want to handle the recursion error, we have an exception to handle that also. Say like we can do like this. Instead of directly calling, we can pass like this. You see, recursion error. If at all, if you want to call the recursion error, this is how. So now you understood about the recursions, what is the maximum recursion limit, and all these things. So the last point we need to understand before going to the decorators is about non-local functions. So non-local function and like the decorator. So non-local functions means like whenever you have a function which is having some kind of scope. So how the scope will be working, till now you learned in this class only. But I will go like one step ahead to help you understand some interesting point. With this, we can stop. So first, if I define a variable at the global level, within the function, I have an outer name. And within that, I have one more function called as inner. So observe, very interesting. If I clear it, you can see that. I have a function. So till now, I have an outer function, right? So let me remove this code to understand. It's a very simple use case. So clear and Python 0 to 8. Somewhere I placed it. Okay. Okay, I placed it outside. Okay, did you see that? I defined a function called as global. So from outside, and I used it. Now, if I define another function called as the inner, so what will happen? When I'm making a call to the outside function, will the inner function will be executed? No. From outside, if I ask this function to be called like inner function, will it execute? No. Why it won't execute the inner function? Because it is not in the outer scope. So this inner function is defined, but within the another function. Sir, can I define like this? Means sometimes we can define if you want to use that context. So for your usage. But sir, how to call this inner function? So if you want to call the inner function, you should go to this and execute. So if you execute it, it will work perfectly. So if you ask like so inner will be executing. But sir, can I execute this inner before it? And before definition, you are trying to ask. Whenever any variable, if you are trying to ask before definition, it will throw this kind of standard error. So what is this error called as? Unbound, so local error. So if you go for like C language, before defining the function, you can call, and after that you can have a definition. So anywhere in the scope, if there is a function definition, it will use it. Whereas in Python, that's not the case. Only after a function was defined, you can make a call, not before that. So that is another point I want to bring to your notice. So within that, if you have some logic, it will execute. Now I am changing this a bit. So I'm making like a small change to it. Did you see in this case what I'm doing? I am defining the same outer, and this time I'm making like a global. Means what are the local changes will not reflect outside, right? To make it reflect outside, we can define as a global. Then this time, if you observe, this is another problem I want to tell you. So here I defined name as like inner function level. Did you see that when I defined it as a global, so whatever you are pacing inner also, it is like inner function level. But when you go outside, it is saying like unaffected. Means you have an outer function, within that you have an inner function. And if you are defining like a global, so which is getting affected? So not this within this function, but outside it is getting affected. You see, this one is not getting affected, unaffected. So that is the usage of global. Now, just I want to help you understand about one more keyword in this particular process called as like non-local. Means if you observe carefully, same like in the previous case, I am using non-local. What is this concept of non-local means? This is another keyword. Which will have its effect only to the one level above, not to the global level. Whenever you have any inner functions, whose value if you want to go to one level above, we need to go for this one. Sir, what if you have a single function, not like this inner functions? Can I still use non-local? In that case, it makes no sense. If you want what are the function changes to go outside, you can just write global, right? Non-local is suitable when you have like a function within a function, like this kind of inner functions. So in that case, it will be useful. So that is all about these inner functions. So I think like I will have some kind of conclusions so that you will understand what's happening. So if a variable is initialized with a global, so changes will be reflected across the script, but not like one level above. But if only one level above, if you want, non-local. So with this, we can stop. And next, we will learn about the decorators in the next class.